In this example, we're going to go ahead and solve the system by hand using the elimination method. Express the solution as an ordered pair. Okay, so remember, a solution will just be a coordinate, basically. And with two equations, two variables, or in other words, when you have just two variables, that coordinate is an ordered pair. If we actually needed three variables, it would be an ordered triple. If we had four variables, it would be an ordered quadruplet, and so on and so forth. Okay, so let's talk about how we solve this by hand. Now, the first thing that we had in our steps, or the first step we had in our steps that we were given, is that we want to get the same but opposite sign in front of either the x or y for both equations. Now, what that means is that for this particular situation, in front of the x's here, we want to have the same number but opposite sign, or in front of the y's, we want to have the same number but opposite sign. And these really do need to be in standard form, by the way. And so if we look at this, notice that there's a 2 here and a 1 here. The least common multiple between 1 and 2 is 2. And between 6 and 8, the least common multiple is 24. So I can multiply top and bottom to get the x's to be the same, or the first equation and the second equation, to get the x's to have the same coefficient but opposite sign, or to have the y be the same coefficient but opposite sign. Either way works. But in this situation, it's actually easiest to get rid of the x's, because if you notice, that's already a 2 there. The 2 doesn't need to change. So as a result, we can just leave it as it is. So what I need to do is I need to multiply the bottom equation by 1. Sorry, by 2, my apologies. Not 1. By 2, to get it to become a 2. Now, if I leave it as just a 2, now notice that I'm going to multiply by 2 on both sides of the equation. If I multiply by just a 2, then we don't have opposite signs, because this is a positive 2, this would become a positive 2 between those two. So instead of multiplying by a 2, let's multiply by a negative 2. And that'll give us opposite signs. Now notice what happens. The top equation, or the first equation, stays the same. 2x plus 6y equals negative 1. For the bottom equation, 2 times, well, notice first of all we need to distribute that negative 2 there. Negative 2 times 1 is negative 2x, and then negative 2 times 8 is negative 16y, and 2 times negative 2 is negative 4. Awesome. Now look what's happened. The x's are the same coefficient, but opposite signs. And that's exactly what we want, because now what we're going to do is we're going to add these two equations together. Because basically, here's the thing, here's the idea behind this. If A equals B and C equals D, then A plus C equals B plus D. That's pretty much what we're saying here. And notice that what happens when we add these together, the x's go away. The x's are canceling each other. They're gone. But the y's stay there. We have 6y minus 16y. Well, 6 minus 16 is negative 10. So it gives us negative 10. Y is equal to the negative 1 minus 4, because it's negative 1 plus a negative 4. So negative 1 minus 4, they're the same sign, so you add them. 1 plus 4 is 5, but they're both negative, so we're going to keep it as a negative. Remember, it's only positive if you're multiplying, and then we'd get a positive 4 out of it. But we're adding, not multiplying. All right, so notice now that we have negative 10y equals negative 5. And this is basically what we get for that step 3. And so now our next step is to get the y by itself, so we're going to divide by negative 10 here. As a result, the left-hand side is just y, the right-hand side is simplified as 1/2. Negative 5 over negative 10, well, 2 negatives gives us positive first of all, common factor of 5, so it gives us 1/2. Good, so 1/2 is our y coordinate, but we're not done. We're only halfway done, kind of. We have half the solution at least. We know the y variable. That means we need the x variable. To find the x variable, I can plug this y equals 1/2 into either this first equation or this second equation. And I want to do it to the original just because it makes more sense in case if you messed up going from here to here, you want to be sure to, plug this into the original to see that you messed up in this process. Okay, so we're going to take this 1/2. Actually, would that prove it? No, it wouldn't. Well, we wanted it to the original anyway. So plug this into either the first or the second equation. It doesn't matter which one. And then simplify and solve. My recommendation for this one is to plug it into this second equation. Because when we plug it into the second equation, this x plus 8y equals 2, just replace y with 1/2. And then 8 times a half is just asking what's a half of 8, basically. So what's a half of 8? Well, that's 4. So it gives us x plus 4 equals 2. Subtract the 4, so we get x equals -2. And what that tells me is that the solution here is actually -2 comma 1/2. And notice that you have to have parentheses around this because coordinates are always in the form of x comma y with parentheses around them. Excellent. And that is, in fact, the solution. Now, you can check this by plugging these in to both of these. 2 times -2 is -4. 6 times a half is 3. So -4 plus 3 is -1. Is -1 equal to -1? Yes, it is. -2 plus 4. -2 plus 4 is 2. Does 2 equal 2? Yes, it does. So that does, in fact, work. But I do want to go ahead and see that you didn't actually have to use that second equation. You could have plugged it into the first equation. So let's see how that would have worked. If we plugged it into 2x plus 6y equals -1, well, we get 2x plus 6 times, positive 1/2 equals -1. 6 times a half is 3, which gives us 2x plus 3 equals -1. Subtract the 3. Gives us -4 divided by 2, so x equals -2. So either way you do it, plugging it into the second equation, plugging it into the first equation, it doesn't matter. You get x equals -2 out of this. It should be that way. Okay. Excellent. So there you go. That's pretty much it. I'll see you in the next video. Have fun.